Richard L. Corsi. Dr. Corsi is the Dean of Portland State University's Massey College of Engineering and Computer Science. He has over 25 years prior to his current position as professor, department chair, and endowed chair in the Department of Civil, Architectural, and Environmental Engineering at the University of Texas at Austin. He is the president of the Academy of Fellows of the International Society of Indoor Air Quality and Climate. Dr. Corsi.
Thank you, Lilia. Slide, thank you. So I'm going to speak about indoor air quality, climate adaptation, and environmental justice, or more specifically, equity. I think everybody realizes we're in the middle of two huge crises at the moment, two big challenges, a horrific pandemic, and the ravages of climate change continue. Out west, we've been seeing historic wildfires that have an undue impact on underserved communities. What we need to do to deal with these events are sometimes contradictory. So for COVID-19, we're told we should have greater ventilation in schools, greater ventilation in our homes, greater ventilations everywhere. For wildfires, we're told to have less ventilation in schools, less ventilation at home, less ventilation everywhere. And so we have these sort of contradictory things we have to do to deal with each of these crises at the same time. And how we do these, and we can deal with both of those things, but there are real equity issues because of the cost of trying to deal with both of those things simultaneously. So I'm going to talk about that in my next few slides. Next slide, please. So underserved communities, they struggle with both of these issues, right? We have multi-generational families in many underserved communities that live in smaller homes, so they're more prone to rapid spread of COVID-19 infection in the household. They lack money for effective controls in the home to control aerosol particles in the air, for example. They may have less quality health care. As Sybil said, many in underserved communities can't work from home, and so they have to go to work. They work in service jobs. There's been a huge job loss in the service industry, and even if they keep their job, the service industry tends to be very lacking in controls for things like aerosol particles. And then if we look at schools, most in underserved communities go to public schools. We saw yesterday that New York City closed all of their public schools, and most of the private schools are staying open. And the private schools can stay open because they're less dense, there's less children in the classroom, they have a lot more money, they can spend money on control technologies to improve the environment for COVID-19. And public schools don't have that money, don't have those controls, and so they have greater infection risks for the students as well as teachers and staff. Next slide. So I'm going to talk about, in my next 3 slides, one technology that actually can deal with both the effects of COVID-19, reducing our dose and therefore risk to associate with aerosol particles that are virus laden, but also can help us deal with particles associated with wildfire smoke, which can be quite harmful, especially to people that have respiratory diseases like asthma. HEPA air cleaners, high efficiency particulate air filters, are a proven technology. They are a great supplement to ventilation when we want to ventilate less. They can give you sort of the equivalent, if used appropriately for a good portable air cleaner, up to 3 or 4 air changes per hour, which is much greater than you typically find on average in an American home. They're valuable in wildfire season. So my wife and I had 2 really good portable air cleaners in our house during extreme wildfire season in Oregon, and they work wonders for us in terms of dramatically lowering particle levels in our home. Significant dose reduction for virus-laden particles that carry the SARS-CoV-2 virus. The problem with them is that they're cost prohibitive for many. So good portable air cleaners like a HEPA portable air cleaner that treats a large space can run you $250, $300. And if you wanted to have multiples of those in a home or one in every classroom in a school, you're running up in the hundreds to thousands to $10,000s of dollars. Next slide, please. So what's happened is there's been some, and this is really exciting for me, is that there's been some really bright individuals who have said, let's solve this problem by making our own portable air cleaners. What if we took a $17 box fan and we purchased a good filter, a MERV 12 or a MERV 13 filter, and we put it up against the box fan and we sucked through the filter as opposed to trying to push through the filter, because if we suck through the filter, it'll seal nicely to the box fan. Can we use that to actually reduce aerosol particles inside schools or homes? Aerosol particles that might be associated with wildfire smoke or might be associated with virus-laden particles that contain the SARS-CoV-2 virus. And these are just results from a very simple test done by one of our new assistant professors at Portland State University, showing on the vertical axis the fine particulate matter concentration in micrograms per cubic meter in a small room in his home versus minutes from when the fan was turned on. And he was running at about 160 micrograms per cubic meter in his house. He used this in a room in his house, and you can see this dramatic reduction in particulate matter from literally a device that cost him about $35 to build, with a MERV 13 filter and a box fan. The problem with doing this is that there's a pretty big resistance in trying to get the flow from a box fan to go through a filter. And so on social media, I threw out the idea that, maybe we should actually build the unit, build an actual portable air cleaner where the walls of the portable air cleaner were MERV 13 filters, so that we could dramatically reduce the resistance through the unit and get a higher airflow. And so, next slide, please. And so a wonderful tinkerer and innovator in Texas built what you see on the left, which he called the Corsi box, which I shouldn't have taken credit for, because he built it within 24 hours of hearing this. And he built this beautiful portable air cleaner where the walls of the air cleaner are actually MERV 13 filters, dramatically reduces the resistance on the fan. And so you can get a much higher flow through it. And the unit that you see here is almost as effective as one of these $250 to $300 fancy portable air cleaners at a fraction of the cost, about a sixth to a seventh of the cost. So one idea here is it possible to get organizations to assist with teaching people, maybe teaching high school students, how to make or to mass produce these low-cost portable air cleaners for schools and homes in underserved communities. So coining the term here, citizen manufacturing, as a way of dealing with two crises at once: the ravages of smoke from wildfires and also the ravages of virus-laden particles in homes and schools associated with COVID-19. Can we deal with both of those and serve underserved communities with these new portable air cleaners that are much lower cost? So I just throwing that out there as an idea for our community and hoping that some people are interested in it. So